Hi everyone, welcome to our channel. So today we're going to discuss about consistency. Okay, so what is consistency and what is inconsistency? So we can solve this using a problem. So first we'll know what a consistency is and what inconsistency is. Okay, so before going to our concept, the students who are watching my channel for the first time, I request you to please subscribe my channel and please share my videos to your friends. Okay, and please support our channel all possible ways. Right. So consistency. So what is consistency? Consistency is extremely important notion in mathematical logic. So in mathematical logic, consistency plays a major role. So first let's see what consistency is all about. A set of formulas. For example, if I have a set of formulas like H1, H2, H3, so on up to Hn. So a set of formulas H1, H2, H3, so on Hn is said to be consistent if their conjunction. So if we perform conjunction on those formulas like H1 and H2 and H3, so on up to Hn has the truth value T for same assignment of the truth values to the atomic variables appearing in H1, H2, Hn. Okay, so it should yield with all the truth values for all the statements. Okay, so that is called, we call it as consistency. So the exactly vice versa is inconsistency. A set of formulas H1, H2, Hn is inconsistent if their conjunction H1 and H2 and Hn implies a contradiction. So contradiction means all false. Okay. Therefore consistency equal to statements can all be true. So the rule of inconsistency is also called as proof by contradiction. So proof by contradiction is nothing but rule of inconsistency. Okay. So that's what contradiction means, all false, right? So if we get all the statements in true value, then it is consistent. If we get all false values or not all true or not all false, then it is called inconsistency, or we can simply call it as indirect proof or proof by contradiction. Okay, so we'll see an example so that you'll get a clear idea about this. Okay, so let's take an example. This is most important. Show that R implies negation Q, R or S implies negation Q, P implies Q, and negation P are inconsistent. So they are not asking question consistent, they are asking inconsistent. Okay, so whatever it is, inconsistent means it should not hold the truth value. Okay, so first let's take P. Okay, so P, so which is nothing but, let us assume, so we don't have P, right? So we have negation P, we have P tends to Q, we have S tends to negation Q, R or S, R tends to negation Q, so we don't have that, right? So let us assume this is rule P. Okay, so next is P tends to Q. Okay, so this is rule P. Okay, so if we have P tends to Q, then we get Q using rule T, 1, 2 and I11. So using I11, P tends to Q, we get Q, right? So next is take R tends to negation Q, sorry, S tends to negation Q. Okay, which is rule P again. S tends to negation Q. So if we have P tends to Q, we can write negation Q tends to negation P. Okay, if we have P tends to Q, let us assume if we have P tends to Q, so we can write it as negation Q tends to negation P. Okay, so like that, here we have S tends to negation Q. So negation of negation Q tends to negation S. Okay, so negation of negation is nothing but Q. So Q tends to negation S. So what do we get? Q tends to negation S, right? So and here we have Q, here we have Q tends to negation S. So if we apply again rule T, 3, 5 and I11. So Q tends to negation S, we get negation S using I11. Okay, right? So here we have up to negation S. So R or S. So here we have R or S, right? The rule P. Okay. So if we have P tends to Q, so we get negation P or Q. So from this rule we get negation R tends to S, right? So negation R tends to S. So again we have, if we have P tends to Q, then we can write negation Q tends to negation P. So here we have seen negation Q tends to negation P. So here we get negation S tends to R. So negation S tends to R. So here we have negation S, sixth one we have negation S, and ninth one we have negation S tends to R. Using I11 we get R. Okay. So rule T, comma 6, comma 9 and I11. The 6 is negation S and ninth one is negation S tends to R. We get R. Okay. So in 10th we get R. And here we have R tends to negation Q. Okay, so R tends to negation Q. So use this is rule P. Okay, so why? Because we have in the premises, right? Now rule T, comma 10, comma 11 and I11. So R tends to negation Q. We get negation Q. Okay, so now here in 3 we have Q. And in 12 we have negation Q. So what is the consistency rule? If we make two premises like formulas, like for example if we have A, if we have B, two formulas, one formula is A, one formula is B, we should apply A and B. If it holds the value true, then it is consistent. Okay. Now in the place of third premises I have Q. Okay. And in the place of 12, I have negation Q. Okay. So 3 and 12. Okay. So let us assume this be true. And negation Q is, if Q is true, negation Q will become false. So what happens in true and false? Obviously we get false. So that's the reason we proved that this is inconsistent. Okay. So when it is consistent, we get all by formulas. If we apply this one and we will get truth value, then it is consistent. But they asked us to show that inconsistent. Obviously, we got false. That is nothing but inconsistent. Okay. So finally, we proved that this is called rule of contradiction. Why? Because we got false. In examination, they may ask you show that given formulas are consistent or inconsistent. Okay. So I hope you understood with this example. So whatever be the example it is, the most important thing is you need to remember rule P, rule T, and I1 to I14 rules and E1 to E22 rules. Okay. So with these rules we can able to solve our problem. Okay. So this is all about consistency, rule of consistency, rule of inconsistency, or proof by contradiction. So I hope you enjoyed the video. So please subscribe my channel and please share my videos to your friends and well-wishers, and please support my channel in all possible ways. Thank you very much and have a wonderful day.